Now in this module, we will be talking about square roots or radicals, whichever term you pretty much prefer. Now, one of the main things that we'll be doing for this course is simplifying radicals and also multiplying, adding, and then simplifying radicals. So, in order to simplify radicals, it's important that you're familiar with perfect squares. Perfect squares are numbers that you can take the square root of without a calculator. You can pretty much just memorize them. Some of the perfect squares include numbers like 1, 4, 9, 16, 25, 36, 49, and I can keep going, but I'll stick with the first 7. Now, the reason these are perfect squares is because you can actually find the square root of these numbers very easily. For instance, the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. And the square root of 49 is 7. You might notice a pattern here. Also notice that 1 times 1 equals 1. 2 times 2, 3 times 4. 3 times 3 equals 9. 4 times 4 equals 16. 5 times 5 equals 25. 6 times 6 equals 36. And 7 times 7 equals 49. Hopefully this helps you see the relationship between radicals and square roots and exponents. For instance, let's look at the number 49, the square root of 49, and 7 times 7. 7 squared, which is 7 times 7, is 49. And the square root of 49 is 7. So basically, you can see the pattern is that when you're taking the square root of a number, it's really just one of the products that you use to get that number. So you can take the square root of many, many numbers, but like I said, not all of them are perfect. The ones that are perfect are the ones that we want to focus on. The ones that are not so perfect, we're going to show you how to simplify those. But if you can memorize this list of perfect squares, simplifying radicals will become a lot easier. And like I said, I only went up to 7. There's 8 times 8, which is 64. There's 9 times 9, which is 81. There's 10 times 10, which is 100. The list goes on and on. Now let's start with some simplification of radicals. Let's start with a very simple one. The square root of 100x squared. And I know you're probably thinking, wait a minute, we only talked about numbers. Where did the letters come into play? There's only one thing that you need to remember when you're trying to find the square root of a variable raised to an exponent. Now let's just look at that first. X times x equals x squared. Now, if I want to take the square root of x squared, that's going to give me the answer of x. So what's really happening is that exponent right there, the 2, is being divided by another 2. And that's how you're getting just a plain old x. So basically, anytime you're taking the square root of an exponent, what you want to do is just divide that exponent by 2, and that will be your answer. Now, what if the exponent's not even? Let's look at something like that. Let's say we have x cubed that we want to find the square root of. Your job here would be to write some factors of x cubed, where one of the factors, for instance, an even exponent. For instance, x squared times x. X squared times x still gives you x cubed. So we didn't change the problem. We just rewrote it in a way that one of them will have the even exponent and the variable that's left, the x, will be just the leftover one. So what happens here is the square root of x squared is x. So that's going to come out of the radical sign. And what's left is this x, because you cannot take the square root of the variable with the odd exponent. Let's go back to the main example, and we'll come back to this in a little bit. Again, the square root of 100 x squared. The number 100 is one of those perfect squares that we were talking about. Since the square root of 100 is perfect, that means I can find the answer without a calculator, and I can continue to simplify. So the square root of 100 is 10. Now, once I have that number, my answer does not need to go underneath the radical sign anymore. Next, we look at the x squared. The square root of x squared is simply x, because 2 divided by 2 gives me 1, which leaves me with just x. So this would be my final answer for this problem. But let's look at a few more similar problems. Let's use a very similar one. Let's use of 100x to the 5th. So really all I did was change the exponent from the first problem to the second. So again, I'm looking at the square root of 100, and I know that I can find the square root of that without any problems, and that's going to give me 10. But I still have this square root of x to the 5th to simplify. Now again, since the exponent is odd, I want to rewrite this variable in two terms. Well, not two terms, in factors, in two factors. X to the 4th times x. The reason I'm picking x to the 4th is because it's the closest even exponent to x to the 5th. Now again, notice x to the 4th times x gives me x to the 5th. So again, I did not change the problem. I just made it easier to manipulate. Now again, I want to find the square root of x to the 4th. So all I'm going to do is divide my exponent by 2, and I get x squared. So that means the square root of x to the 4th is x squared. So now when I look at this x, can I take the square root of this x? No, I cannot. So that x remains under the radical. Notice the pattern that once you find the square root of something, it gets placed in front of the radical sign. And anything that you do not find the square root of remains underneath that symbol. So that would be my final answer. A few more. What if the problem you have, again, we'll use something very similar. What if the problem you have has a number in front of the radical? Now, in problems like this, what happens is, once you find the square root of anything that's underneath the radical symbol, it gets multiplied by whatever is in front of here. In our other examples, there's no number in the front of the square root. So when there is no number, again, remember, you can consider it just 1. So 1 times any of these things just would have given you the same answer. So let's come back here. We have 2, the square root of 100x to the 6th power. Again, I'm dealing with these easy numbers so you can see the process. The square root of 100 I can find. So the square root of 100 is 10. So that means I'm going to bring down this 2. And since I can find the square root of 100, I'm just going to cross it out so I don't look at it again. The square root of 100 is 10. So 10 is going to get multiplied by the number that was in front of the radical. And again, x to the 6th, the square root of that is simply for me to divide the exponent by 2, and I get x cubed. So my answer is going to be this product. 2 times 10 is 20, and x cubed. That is my final answer. Again, notice there is nothing underneath the radical sign because I found the square root of 100 and x to the 6th. So my answer is 20x cubed without my radical symbol. Let's look at another one like this. What if instead of a number in the front, we have a variable like x. And I'll just use the same problem over and over again so you can see what's changing. Again, you want to ask yourself, what root of? 100 is a perfect square. So the square root of 100 is 10. So what's going to happen is, again, I'm going to bring down my x because that's in the front. And whatever I find the square root of is going to get multiplied by that number in the front. So since the square root of 100 is 10, I'm going to multiply 10 by x. The square root of x to the 6 is x cubed. Now my job is to just simplify this. X times x cubed is simply x to the 4th power. 10 by itself. My final answer is 10x to the 4th. Now let's just look at a few more problems that are a little bit more involved. xy to the 4th square root of x to the 10th y. And let's also look at one more. 2x the square root of 49 x cubed y to the 6th. Now I know what you're thinking. In the other problems we only had one letter. Now there's two. It doesn't matter. Look at each one individually and simplify it. So here in this first problem, notice we have xy to the 4th in front of the radical symbol. That means anything that we find the square root of in here is going to get multiplied by this. So let's look at the first one, x to the 10th. Can I find the square root of that? Yes, I can. Since 10 is even, again, we're just going to divide that 10 by 2, and we get x to the 5th. So let's bring down xy to the 4th. So you can see that we're not changing anything, we're just bringing it down. X to the 10th becomes x to the 5th because that is the square root of x to the 10th. And the square root of y, I cannot simplify that. It's going to get left underneath the radical symbol. Now, this isn't exactly wrong, but it's not complete either. What we need to do is simplify this product here. I have x, y to the 4th, x to the 5th. This is all multiplication. There's no need for me to have the same variable in one product. So x times x to the 5th gives me x to the 6th. Y to the 4th doesn't have anything to simplify with. And I'll be left with y underneath the radical sign because I was unable to. Now, same process, but now with some numbers and letters together. Again, whatever we find the square root of in here is going to get multiplied by 2x. So let's just rewrite our 2x so we can multiply everything that we bring out of the radical. Again, can I find the square root of 49? Yes, I can. It's a perfect square. The square root of 49 is 7. Notice I'm bringing the 7 here to be multiplied by the numbers in front of the radical. X cubed can be broken down into x squared times x. Again, the reason I did that is because the exponent is odd. It's easier for me to find the square root of variables raised to an exponent when they're even. So the square root of x squared is simply x. I cannot find the square root of this x because there's only one. The square root of y to the 6th is simply y cubed because 6 divided by 2 is 3. Now the only thing that's left under my radical symbol is my x. So again, let's simplify. We have 2 times x times 7 times x times y cubed. We need to simplify that. We have numbers everywhere, x's everywhere. So 2 times 7 gives me 14. X times x gives me x squared, and there's nothing to multiply my y with, so I'm just going to rewrite it. And again, this would be my final answer. Now let's look at some radicals where we will be expected to multiply and then simplify, because in those previous problems, that's what we were doing. We were just simplifying. For example, the problem 4 square root of 2 times square root of 6 minus 2 square root of 3. Now you're probably wondering, how the heck are we going to do this? Well, the same way, let's compare it to something that we've done successfully already. Something like 3x times 3 minus x. Okay, in a problem like this, you would just distribute. You would multiply 3x times 3 and 3x times minus x. We're going to use that same concept up here. We're going to multiply 4 square root of 2 times the square root of 6, and we're going to multiply 4 square root of 2 times negative 2 square root of 3. Now there's only one thing you really have to remember here. What's going to happen is you're going to multiply the number in front of the radical symbol with other numbers in front of the radical symbol. In this one here, since there is no number in the front, again, you can assume that it's 1. This one has a negative 2. You're also going to multiply numbers that are under the radical with other numbers that are under the radical. So what happens here in the first one? We have 4 times 1 square root of 6. 4 times 1 gives me 4. 2 times 6 gives me 12. See how simple that was? The next one is 4 times negative 2, which is negative 8, and 2 times 3, which is 6. So now our job, now that we've actually multiplied, our job becomes to simplify the same way we did before. Now before, we were simplifying perfect case squares. In this case, the number 12 and the number 6 are not perfect squares. So the same way that we simplified the variables with odd exponents, we broke them down into 2 factors, we're going to break down the number 12 into 2 factors where at least one of those factors is a perfect square. So I'm just going to rewrite this 4. Now instead of writing 12 as 12, we're going to write it as the product of 2 numbers. The numbers that I'm going to choose are 4 times 3. Again, notice 4 times 3 gives me 12. I did not change the problem, I just changed the way it looked. The reason I chose 4 times 3 is because 4 is a perfect square. The square root of 4 is 2. So again, once I find that square root, I need to bring it outside of the radical and multiply it by the number that's here. So let's bring down the 4. The square root of this 4 is 2, so it's going to get multiplied by it. And what's left under the radical symbol is a 3. You always need to simplify. So 4 times 2 is 8, square root of 3. Now let's look at this one. Negative 8, square root of 6. Now you can try to simplify this, but I already know that 6 does not have any factors where one of them you can at least find the square root of. For instance, 2 times 3 gives me 6, but I can't find the square root of 2 or the square root of 3, so that doesn't really help me. So all I'm going to do is just bring down the negative and this square root of 6, and this will be my final answer. Now the reason I didn't combine these is because they are not like radicals. So the same way that you need to have terms alike in order to combine them, you also need radicals to be alike. So again, let's look at something we've already completed successfully. 3x and 5x, they are like terms. So yes, I can combine them. Now when we look at radicals, in order for radicals to be alike, they have to have the same number underneath the radical sign. So in this case, 2 square root of 3 and 3 square root of 3 are like radicals because they both have the square root of 3. So if I put a plus sign here, my final answer would be 2 plus 3, which is 5 square root of 3. So now that we know what a like radical is, when we go back to that problem we were looking at, 8 square root of 3 minus 8 square root of 6, these are not like radicals because there are different numbers underneath the symbol here. So let's try a couple more problems where we will have to simplify. Okay, in this problem again, keep in mind you're multiplying numbers in front of the radical with other numbers in front of the radical and numbers under the radical with other numbers under. So I'm going to take the square root of 12 and multiply it by 2. And I'm also going to take the square root of 12 and multiply it by negative 3 square root of 5. So what happens here? The square root of 12 and 2. The square root of 12 doesn't have a number in front, and 2 doesn't have a radical. So what happens here is, remember I told you about that invisible 1 that's already always here. We have 2 times 1, which gives us 2. And since the square root of 12 doesn't have a radical symbol to multiply with, we're just going to bring it down. Let's look at the next one. Square root of 12 times negative 3 square root of 5. We're going to get here 1 times negative 3 and 12 times 5, which is 60. Now that we're here, just like before, you always want to see if you can simplify any further. And although 12 and 60 are not perfect squares, they do have factors that are. So, let's start with the 12. Let's bring down the 2, and instead of using 12, let's use some factors of 12 where at least one of them is a perfect square. So 12, we can use 3 times 4. Now 3 is not a perfect square, but 4 is, and that's why I chose it. So that means when I find the square root of 4, which is 2, I'm going to bring that 2 out and multiply it by the 2 that's in the front. So this 2 comes down, the square root of 4 is 2, and I cannot find the square root of 3, so that remains under the radical, and I'm just going to simplify this. Now we have this number that's a little bit bigger. Now, maybe the first time I break down the factors, I don't find a perfect square. So I might have to break it down more than once, not like the number 12 where I only had to break it down once. So let's look here. Instead of writing 60, let's write 20 times 3. That gives me 60. But again, 20 is not a perfect square, neither is 3. But the number 20 does have some factors where there is at least one. So for instance, some factors of 20 would be 4 times 5, and I'm just going to bring this times 3 down. Now let's go through. Can I find the square root of 4? Yes, I can. The square root of 4 is 2. And now let's not forget about this negative 3 that's here. So I'm going to bring down the negative 3, and the square root of 4 is 2, so 2 is going to get multiplied by negative 3, and underneath the radical sign I have 5 and 3, which neither one of them I can find the square root of, so I'm just going to put them back together. 5 times 3 gives me, so again we need to simplify. Negative 3 times 2 is negative 6 square root of 15, and this will be my final answer.